Section 15b.2, question number 3, page 367. In this question we're asked to find the gradient of the tangent to a certain number of functions at a variety of points that are given. Part A asks us to find the gradient, the gradient of the tangent, to y equals the root of 1 minus x squared at x equals a half. So first I'm going to start by rewriting this into exponent form. So it'll be 1 minus x squared all to the power 1 half. Now I'll take the derivative. I'll find the gradient function of this by employing the chain rule. So I'll bring the 1 half down in front, and then I'll subtract 1 from a half to get negative a half, and then I'll go in the inside and take the derivative of the inside, which gives me negative 2x. Okay, I could simplify this a little bit if I wish, but it's not really necessary because we're going to go on to another step now and substitute the 1 half in for x here so we can actually find the gradient of the tangent. So I indicate the gradient with an m, and that is the gradient function evaluated at x equals a half. And then I just rewrite all of this and substitute a half in for the x. And then I just start simplifying here. So half squared just gives me a quarter, so I go to half times 1 minus a quarter, all to the negative 1 half, and then negative 2 times a half is just negative 1. And so maybe I'll just leave that out there for now. I'll worry about the bracket here. So that's 3/4 to the negative 1 half multiplied by negative 1. And then when I take the square root of this, the negative will give me the reciprocal of this. So then I get the square root of 4 over the square root of 3. We know the square root of 4 is 2, so it'll be 2 root 3, because that negative flips this fraction, gives me the reciprocal, times negative 1, and then just simplify. The 2's will cancel out here. So the gradient of the tangent to y equals the root of 1 minus x squared at x equals a half is negative 1 over root 3. I suppose if you were really sticky about this, which I don't tend to be, we could rationalize this by multiplying the top and bottom by root 3, just so that we don't have the root in the denominator, which would give us then negative root 3 over 3. But I'm not usually that picky about it. I'll just leave it in general as the 1 over root 3. But this is how we could rationalize it to get that root out of there. Okay, let's move along to part B now. The function is y equals 3x plus 2 all to the exponent 6, and we're going to evaluate that tangent at x equals negative 1. So the gradient function will be found by employing the chain rule to differentiate this function. So I bring the 6 down in front, I leave the function on the inside as it is, and then I subtract 1 from the exponent to give me 5, and then I go on the inside and take the derivative of 3x plus 2, which just gives me 3. I'll just bring that to the front just to tidy this up. I know I didn't do that in the last example, but didn't really make a huge difference in the last example, just sticking a negative in front kind of thing. Anyway, so here we go. We'll now find the actual gradient of the tangent by evaluating the the gradient function at x equals negative 1. And that will give us then 18 quantity 3 quantity negative 1 plus 2 all to the exponent 5. And negative 3 plus 2 gives me negative 1. Negative 1 to the exponent 5 is just negative 1. And negative 1 times 18 is just 18. Sorry, negative 18. So the gradient to 3x plus, the gradient of the tangent to 3x plus 2 all to the exponent 6 at x equals negative 1 is negative 18. So now for part C, try to squeeze this in at the bottom of the page. Y equals 1 over 2x minus 1 to the exponent 4. We'll evaluate the gradient of that tangent at x equals 1. Keep things nice and simple. So I'll rearrange this, or rewrite this to be 2x minus 1 all to the negative 4. It'll allow doing the or differentiating this a little bit easier. So now I bring the outside exponent down in front, leave the inside part just as it is, and I subtract 1 from the exponent. Negative 4 minus 1 gives me negative 5. And then I go on the inside and I multiply, or I take the derivative of the inside part, which is just 2. I'll bring that to the front just to tidy this up to give me negative 8 times 2x minus 1 all to the negative 5. So that is the gradient function, and now I will evaluate that gradient function to find the gradient of that tangent when I evaluate dy by dx at x equals 1. So I get negative 8 multiplied by 2, quantity 1 minus 1 all to the negative 5, too many brackets. There we go. And so we got negative 8, and then 2 minus 1 is just 1 to the negative 5, making this simplification much easier. So therefore, the gradient of the tangent to 1 over 2x minus 1 to the exponent 4 at x equals 1 is negative 8. Part D, the equation is 6 times the cube root of 1 minus 2x, and we're going to evaluate that tangent at x equals 0, or the gradient of the tangent at x equals 0. So I'll rewrite this now as 6 quantity 1 minus 2x to the 1/3, because the cube root written in exponent form is 1/3. And so the gradient function will then become 6 times, and I'll bring the 1/3 down in front, times 1 minus 2x as part of the chain rule. Subtract 1 from 1/3 gives me negative 2/3. Then I go on the inside here, and I take the derivative of the inside, which is negative 2. And I'll just simplify this a little bit. So 6 times 1/3 would be 2, and 2 times negative 2 gives me negative 4. All to the negative 2/3. And then when I find the gradient of the tangent, I'm going to evaluate the gradient function at x equals 0 in this case. That's what's asked for there. So I get negative 4 quantity 1 minus 2 times 0 all to the exponent 2/3. So 2 times 0 is just 0. 1 minus 0 is just obviously 1. The actually I can just do this quickly. So the 1 to the power negative 2/3 is just going to be 1, and 1 times negative 4 is just going to give me negative 4. Part E, y is 4 over x plus 2 root x. Notice how we're slowly increasing the challenge of each of these questions, and that's going to be evaluated at x equals 4. Hopefully that 4 will give us a nice, or a number that will be easy to work with when we take the derivative. So it's going to be 4 times x plus 2x to the 1/2. So that root of x here in exponent form gives me x to the 1/2. And because all of this is in the denominator, I'm going to raise that to the negative 1. And now I find the gradient function by taking the derivative of this by using the chain rule. So I have 4, and bring this negative 1 down in front, so times negative 1. Leave the inside here just as it is. I'll subtract 1 from negative 1 to give me negative 2. Now I'll take the derivative of the inside, and that gives me the derivative of x is just 1. And then I take the derivative of 2x to the 1/2. So I've got 2 times 1/2 times x, and then I subtract 1 from the 1/2 to give me negative 1/2 there as the exponent. And now I can just simplify, well, can't really simplify a whole lot, but negative 1 times 4 is just negative 4. X plus 2x to the 1/2 all to the negative 2. And then just simplify this a bit, so we've got 1 plus, and then 2 times 1/2 is just 1, x to the negative 1/2. And now I will find the gradient of that by evaluating the gradient function at x equals 4. And quite interesting, as I had mentioned before, with this 4 being substituted into the equation here, we've got these square roots in there, so that will help simplify the whole expression. So I just substitute all this stuff in, and then I can just start simplifying here. So I've got the square root of 4 is 2. 2 times 2 is 4. So inside this bracket I've got 4 plus 4, all to the exponent negative 2. And then here I've got the negative, basically not the negative square root, but the reciprocal of the square root of 4. So I've got 1 plus 1 over 2 as this, because the square root of this would be 2, and then take the reciprocal of that, and that gives me 1/2 here. And then I start simplifying in here again, so we've got negative 4, 4 plus 4 is 8, negative 2, and then 1 plus 1/2 is 3/2. Then I take I square 8, gives me 64, and I take the reciprocal of that is 1 over 64. So negative 4 times 1 over 64 times 3 over 2. And then when I put it all together, negative 4 times 3 is negative 12, and 64 times 2 is 128. And then I can just simplify that down. So therefore, the gradient of the tangent to this curve at x equals 4 is negative 3 over 32. So it's a pretty gentle slope in the negative direction. And f, part f here, so you've got y equals x plus 1 over x cubed. And we'll evaluate that gradient of the tangent at x equals 1. And again, I'll just simplify this a bit, so x plus x to the negative 1 all cubed. The gradient function now, again, employing the chain rule for this derivative. So I'm going to move this 3 down in front, subtract 1 from 3 to give me 2. Now I'll go on the inside, take the derivative of the inside, so the derivative of x is just 1. The derivative of x to the negative 1 is negative 1 because I bring that down in front, and then I subtract 1 from that exponent to give me negative 2. Now I'll simplify a little here. So x plus x to the negative 1 all squared, 1 minus x to the negative 2. And evaluating to find the gradient of the tangent, evaluate the gradient function at x equals 1. So substitute 1 in for all the x's. And then just start simplifying. So I'll get 3. The 1 raised to the power negative 1 is just 1. And that'll be squared eventually. And then again, 1 raised to the negative 2 is just 1. And so then, once I see that we got 1 minus 1, which is just 0, everything else is just 0. So the gradient of this cubic function, when evaluated at x equals 1, is 0.